I'm Zach Eriksen. I'm going to give a talk on power of extensions. I don't know. I do Swift in my free time, and a lot of open source. So I'm going to just be talking about extensions in Swift. They're a very common kind of pattern in Swift. Not a lot of people kind of, I guess, not a lot of new people understand the power of extensions and what they can do for Swift and solve problems. So I will just literally be talking about the book of Swift. So we'll just be going through the syntax right here. It's just extension bool. So bool is just, true or true or false. So this is a Boolean. So if I had true, let's see what I can do on it. If I do a dot syntax, Swift is a dot syntax language, so I can press dot and see all the functionality of this. So that's it. I can only see the value and I can just toggle it. Really, that's it. There's no other kind of cool functionality to it. So an extension allows me to potentially add, extra functionality into a class that I don't own, or just an object that I don't own. And it doesn't necessarily need to be a class, So I can just see, and then, whatever print self. That's pretty basic. So now if I do true, I can see dot, I can see XYZ. But I think it needs to just be below this because it's a playground and it's just plain funny. So XYZ. So now I can just, call XYZ, and I've added this to this. This is not in the standard Swift library, but Boolean is. So if I go into here, you just see the Swift standard library and that stuff. So I don't own Boolean, but I can extend on it. That's the basic idea of an extension. You can do a lot more stuff with extensions, and I'm going to pull up the book really quick to just kind of copy and paste some stuff in that are some call outs of what an extension is. So an extension is something that can add a computed property instance. This is just a variable. It's not like a variable that you can set in necessarily, but it's a variable that you can just put there that you can always get. You can define functions or methods. You can provide new initializers. You can define subscripts, which are kind of like if you've ever accessed an array by index, that is a subscript, and Swift lets you make custom subscripts, which is pretty cool. I've never used it, so take that with a grain of salt. And you can define and use nested types. And probably the most cool thing is that you can extend a current type with a protocol, with an extension. So I can just say that, a Boolean is, something, I guess, equatable or something like that. So I can extend it more and add more type conformance to it. So that's the basics of extension. Let's kind of dive into each of those facets I was talking about. So computed property is like a variable. Like I said, so we have the Boolean computed property now. So if I say true, I can check is false, and it'll just return true if it's false. Obviously, it'd return false if it's true. Another kind of default Swift is the exclamation mark. This is actually really hard to kind of read. It's, true, but then at the very beginning, it says not true. So it's kind of hard to read. So Swift being a more sentence-based grammatic language, it really tries to make everything read as a sentence. It's kind of the origins of Smalltalk and Objective-C. Everything kind of reads very verbosely, but it makes sense because everything reads. So kind of using this syntax is a little bit better for Swift, I would say, because you can just check if something is false instead of, kind of like this. But that's just a simple example. Then another example I kind of like is an array. Yeah, not a fan of name spacing. An array, you can only check if an array is empty. But a lot of times I'm like, wait a minute, I just want to check if it's not empty. So, if you wanted to, you could just extend the array. And now every single array that you have, integer array, or, I guess a string array, or anything like that, you can check if it is empty or not now, or is not empty, I mean to say. But those are pretty simple examples. Those are just kind of, some, hey, I will return this value. This always returns the value. So essentially, it's like just a get. So it's only getting this value. You can also set up a get and set value. So like, let's say you wanted to save something to user defaults, you could also add something like that. But that's just a further example. It supports all computed properties. The only thing you can't do is like set a value. So you can't just like do this. This is not valid in Swift. For an extension, at least. You have to do all these definitions, because technically this is a definition. So what Swift does, and I hate to like dive into Swift right now, but like technically like this is a definition, and this equals false just gets synthesized into an internal initializer. So that's why it doesn't really work in extensions. It really needs to be defined in a class or a struct. So it would work if I had, a struct ADA. That's a good topic. It would work for like this, because then it would just synthesize it, but it doesn't work for extensions. So you can only have computed properties. So that means that you need to give the value at runtime. So that's just computed properties. We can also make initializers. So let's say I wanted to make an initializer for a Boolean. I wanted to create a Boolean, but I want to initialize it with equating two values of an integer. So I want to say I have a Boolean with the value of 10 equals 10. Well, that's true, right? I mean, I can make it more complex and be like, 10 to the 0th power or 1 power or something like that. And then, this would equate on the right side, and then the Boolean would be true or false. I mean, essentially it's as, simple as this. But I'm just kind of showing the, functionality of we're creating a Boolean, and we can create different initializers for this. So like in theory, you could create an initializer for like a URL, and you could, fire off a URL request, and then you could get back at the end of it, true or false. So that's kind of the power of an init, or adding other inits. Really, ideally, whenever you make an object, there is one mainly one concrete initializer that is really the core kind of job of it. Maybe there's a few that kind of, really deal with like self.value equals value, but a lot of them will just use one initializer to kind of pipe its values through. So it's nice to be able to add some flavor to it, to be like, hey, maybe you want to add some configuration objects to this and pass it in, and then we manage that and that stuff like that. So that's just an example of making one initializer for a very simple type Boolean. But again, we can go further and make functions for this Boolean. So now we can say, Boolean, 10 is, whatever, but then we could also add at the end of it flip. And I'm not going to do that because that doesn't really make sense. But now we can flip a Boolean, which is really just like flipping a coin, right? It's random. Like toggle is toggling it on and off. It's like a light switch. So if it's off, it goes on. It's on, it goes off. But flip, this is just, a value I added. It would just like flip it and make a random value. So it could be true if it's true. It could be false if it's true, whatever. It could be anything. Notice that there's an error, or, I guess, yeah, an error here, because it's trying to mutate a value that's immutable. This is like a Swift issue. You can either make a function mutating and mutate the self value, and if it's a struct, then you have to deal with that, like causation of that. Or you can just return a value, but I guess that's another topic. If I had var value equals true, and then I just flip value, then I have a local variable that I can mutate, and that's why this works. But I can't just mutate it after an initialization. Really weird. I don't understand why Swift doesn't support inline mutation. Like I just initialize this value, I should be able to mutate it until it's assigned to a variable or a property. Like you can't even do this. One of my Swift quorums, I don't really like it, but whatever. Okay, I'll look into it more. All right, so my least favorite extension thing, because I've never used it, is defining subscripts. You've normally seen a subscript in an array. If you see 1, 2, 3, 4, or 1, 2, 3, to access that element, I want to access the 0 element. I want to get number 1 or value 1. So I'll do a subscript of 0, and I'll get the value 1. You see it on the right here. So that's a subscript. You can also add your own subscript. So this is a stupid one. Please, this is a disclaimer. Do not ever write a subscript like this. You should just use a function. But I couldn't find a good example of it because subscripts automatically just like get rid of the parameter name. So if I did it an init or an int, sorry, not an init, an int, it would collide with the current subscript that I just showed right here. So if I actually look into this really quickly, it's just, this is cool. You can see that here's the subscripts. I can see that there's the index one that I'm talking about, where if I put in 0, I get the 0th index. You can also do a range, key path, but here's mine where it's a filter. And now I can write a closure inside of this to filter the array down to only ones that are multiple of 2. So only 2 would exist in this array. Again, this is a bad example. Never do this. It's the only example I could get that's actually valid in some sense. So one of the cooler things, which I don't know if it's actually that cool, kind of this like, you know, extensions being like one time only, like, why would you define an internal type or a nested type? Why wouldn't you define it outside and bring it in? Maybe it depends on some things, but I made this stupid type called token, and it's equal to, less than, or greater than, and then it has these special cases to or and some tokens, just because I was lazy and didn't want to do a lot of functions. So now I have this initialization function that takes a Boolean that I can then pass in a value of 5 and then check, is it equal to, or is it greater than, you know, dot random. We'll do like 5 dot. So I can do something like this now, and now I can add, you know, even more on that. But this token itself is a part of Boolean now. So now I can see that this token is accessible through Boolean. It's not just some thing that lives outside of this. You know, it's not just, oops, my gosh, it's not just right here. It's actually in the namespace of Boolean. So that's pretty cool. But it's also kind of, you know, hidden. Like I would never know that. I have to look for this, you know, so that, it's give and take. But yeah, it's pretty cool that you can define types inside of this. You can't define protocols inside of anything, just FYI. This is a Swift thing. You can define anything like this. Whoops. That bit's a little extra, but this will give an error because it's defined inside of a scope. It cannot be nested inside of any declaration. So just know that the only exception to this rule is protocols. Protocols literally have no namespace. They are public protocols. Every single protocol is on a parallel line, or not a parallel line, but on the same line as every other protocol. Even like protocols defined in Swift, they're all the same. So I want to talk about my favorite part, adding protocol conformance with an extension. Sounds interesting. Sounds pretty cool. But let's say we have this. I just deleted a bit. Just let's pretend it wasn't there. I had that for a little bit before. But a lot of times in Swift UI, similar to Compose, we have text views, and those text views only deal with strings. In most cases, some are kind of special, and they have you know, images or other things like that. But in most cases, they're just a string. So I have this really cool view right here. But I want to make it cooler. And so how can I do that? Well, let's extend string to be a view. And I mean, that's pretty simple. Like I just said before, text is, you know, the string, or the string is a part of text. So I can just say self, because that is the string itself. So I can now promote this to just use a string, because now a string is a view. So that's kind of the cool part about protocol conformance. You can just kind of take a type that exists and you can add conformance to it and kind of spice it up, I would say. So you can get like some spicy views right here. I guess I need a VStack for all technicality, but this is pretty cool. This is something I do in some of my personal projects when I'm super lazy. I'm like, I just want to type in some strings and get a view. So pretty cool. It's nice though, because I can still add padding. You know, it's nothing different. It's the literally exact same thing as a text. So yeah, I think that's pretty cool, because like, I mean, if I wanted let's say UI image, I wanted to just take, or I guess, yeah, let's just say UI image. How about that? That's a simple example. And I wanted to make that a view. Then I could, you know, just say, oh, well, the body or the view of a UI image, I'm defining all UI images view. So I would just use an image and pass in UI image, and I can just say self. So again, it's that self. I'm just defining the view for the data. That's really kind of what Swift UI is behind. So now I can just say UI image, and I can just pass in, whatever I want. And maybe I just want to pass in a, oh, this is funny. You can do the exact same thing with image. That's why I'm laughing. It's just like, it doesn't even matter at this point. They're exactly the same thing. So this is still like, I guess this behind the scenes, which might come with some issues of its own, but yeah, just a little example there. Get rid of this. Okay, so other than that, protocols just get a little bit more powerful because they add this idea of a where clause. Almost done. Okay, cool. So this where clause is more specific on generic types. There's generic types of okay, how do I explain generic types quickly? It's a type that has this kind of abstract name, not really abstract, but it's like, it's a value that can have multiple different types. So I guess it's literally array, I guess is my example. So an array can have integers, but it can also have strings. It can also have Boolean. It can also have, it can have anything because an array uses a generic type. If we look at an array itself, it uses this alligator syntax, crocodile, if you may, but it defines this element, and this element is generic. And when anyone says generic, they are not talking about a type. They are not talking about any type. They are talking about generically over all types is what a generic function, generic object means in a sense. But Swift takes it a step further. We understand that array is a generic type, but now Swift allows us to write this where clause where I can say where this generic type is something. And I give this type a little bit more scope, a little bit more defined in what it's talking about. And now element is equatable. What does that mean? Well, normally if I have this array of 1, 2, 3, whatever, the array itself only knows it as like a generic type, which is kind of weird. I guess let me just make a super quick example of this. So if I have this value right here, and then I say value v, if I have this function in here, I don't really know what value is. Like you just don't know what it is because it could be an int, it could be a string. So when I type in value and I press dot, I don't get anything. But let's say I wanted to define a little bit more. I wanted to add a protocol onto that generic to add some kind of properties or functionality to it. Specifically up above, I added equatable. So what does that mean? What can I do with this? Well, now, I mean, it doesn't show anything, but now I can add this kind of equals now. I can check if v equals another v in this sense because I've added the conformance of equatable. So let's check what, function I made on an array. I pretty much made this computed property called is equal. It only returns true if the entire array is all equal to itself. So if we had an array of one element, it would return true. If we had an array of 5 elements and they're all 1, like the integer 1, it would return true. So we'll just show that really quick. It just reduces into self, blah, 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 and just checks the count. So now I can just say like, is this is equal? I can check 0 and then 1. This should be false. This is not is equal, but 1 of 1 is equal. But like I said, array is generic. So I should be able to say hello and then world. Oops. And so now I'm giving it a string instead of that. And I can check if that is equal. And then I'll check one more to say if, hello world is equal to hello world. So now running all this, if you look on the right, oh, did I get a little error? Okay, whatever. It's just not choosing. This would return true. This would return false. Yeah, playgrounds never work. This would return true, and this would return false and true. But this is only doable because of I'm saying that the element is equatable. If I just take out this whole where clause, you're like, what does the where clause do? Why do you have it in there? Well, I can't use contains. Well, what is contains, and this is pretty cool, and I think this is a good, damn it, one sec, let me just put that back so Swift actually knows what things are. It kind of broke it there. But if I go into contains, it goes into this function, which takes in an element. But if you look at the very top, this is just an extension on an array where the element is, oh, damn it, that's not the right one. I'm sorry, I clicked a little much. But you can see right here, it says equatable right here at the very top. So this is an extension on an array where the element is equatable, which is the exact same thing that I have. So now I can use the functionality of the where clause for specific extensions. But yeah, that was a mouthful. Are there any questions?
I have a question. Is it possible to write an extension function over something that's like, I think the equivalent to Kotlin in iOS is nil. So like in Kotlin, you can write an extension function over something that is, so like you have a class that's named blah, and you can write an extension function that says, hey, if it's blah and optional, that basically you can call this, you can call this function. So it also can turn it from an optional to non-optional. Yeah, so like, is there something like that? I guess there is, maybe.
Yes. So exactly what you're saying. Optional is just an enum for Swift. So it's an enum that has a value or doesn't have a value. So we can extend on that. And the nice part is optional is still like, I guess I can write an unwrapped function that, you know, just unwraps the element, or I guess it would be value or whatever. Oh my gosh. Self dot, I don't wait. Oh, it's wrapped to value. That's it. So then we can run this and I can just say self and then, you know, bang here. And now I can say on any, you know, optional return thing, I can just say unwrap on here and I can get an unwrapped value. But I like, so we can do that for optional, but I think for Kotlin, you can do more like kind of function extensions or something like that. Like Swift has this thing where it's like, let's say I wanted to make an extension on void. Well, for Swift, okay, void's a bad example, but oh no, never mind. Sorry. Void is a non-nominal type, so we can't extend on it. What does that mean? Like, what the hell? What are you saying, Zach? I can't extend on a function, like a generic function like this. Can you do this in Kotlin? Where it's like, you can add, like, I think you can get a little bit closer to the syntax of like, kind of just generally functions have some extension versus something else. But Swift, you have to have a concrete type. You can do protocols. So I can, sorry, if you wanted to talk, interrupt me. I'm just going to say, if you wanted to do, you know, an extension on protocol, you can, because equatable is a protocol. But yeah.
So like in your example, you can do an extension on optional and then do a where to a struct, right? So you can, so like you can say where this this struct is optional, you allow this to do something. You know what I'm saying? Does that make sense?
Yeah, that makes sense. But we'd have to say like
that's something I've used recently in an extension function in Kotlin. So was wondering if it sounds like the same functionality exists.
We can't do that in Swift.
Oh, you can't? Okay.
If anyone knows how to do that, that'd be amazing. But like the only way to check if a value is class is to check if it's like any class. But structs are themselves have no type. There's no way to check a struct versus another struct or anything like that. But so you could probably write it like I was writing where wrapped is any class, and then this would most likely only work for classes. Yeah, okay. Yeah, whatever. It wants to write it like this, but I think you could write it for like classes, but like structs themselves don't work. So yeah, I guess super quick. Let me just struct. And then if I wrote a class, it'd be, that's fine. So then, I hate writing pseudocode like this. P and then ASD dot. This would have unwrapped. No, it doesn't. I don't know. That's where like Swift falls short. It doesn't have that separation of like class versus like struct built into protocols. They're built into the language, so it's a little bit harder to see because any class itself is just a type alias for any object, which is just a type alias. And that's where it loses me. I don't know. Cool. Any other questions? Cool. Awesome. I'll stop.